Hey everyone, today we are diving into a tool that's become pretty much essential for modern software development, SonarQube. We're going to break down exactly how it works as an automated guardian for your code, making sure everything you build is clean, safe, and solid. But let's kick things off with a question. Think about your team for a second. In that mad dash to ship new features and hit those deadlines, who's really standing watch over the quality of your code? Who's making sure it not only works today, but is also secure and easy to maintain for tomorrow? The tough reality for a lot of teams is nobody, or at least not until something goes horribly wrong. Code quality often takes a back seat, and it only gets attention when a nasty bug makes it to production or a security hole gets exposed. This is the exact problem SonarQube was designed to solve. So here's our game plan for this explainer. First, we'll talk about the code quality problem itself. Then we'll meet our automated reviewer, SonarQube. We'll get into the nitty-gritty of what it actually finds, see how the analysis works in a real workflow, and finally, we'll put it all together. Let's get to it. Okay, first up, code quality problem. It's so easy to just think of bad code as a minor headache, but the truth is, it's a minefield of hidden dangers just waiting to go off. And this slide really says it all, doesn't it? Unchecked code is like a castle with crumbling walls. We're talking about huge risks here. Security breaches that can completely wreck your reputation, technical debt that just slowly strangles your ability to build anything new, and those awful regression bugs that have you fixing the same old problems over and over. It's just not sustainable. So, how do we deal with all that chaos? Well, let's move on and meet the solution, your very own automated code reviewer.
So what is SonarQube? At its core, it's an open-source platform for constantly inspecting your code quality. It automatically scans everything you write to hunt down bugs, uncover security vulnerabilities, and just make sure your whole team is following the same playbook.
You know, if you remember just one thing from all this, make it this. SonarQube is your automated code reviewer. It's like having a senior developer on your team that reviews every single line of code, instantly. It never gets tired, it never has a bad day, and it knows the rulebook by heart.
Okay, so what is this automated reviewer actually looking for when it scans your code? Well, its analysis is built on 4 key pillars.
First, the obvious one, bugs. These are the issues that are probably going to cause your app to act weird or even crash. Think about things like null pointer exceptions or subtle logic errors, the kind of stuff a human might totally miss during a code review, but a machine will spot every single time.
Second, and this is a huge one, vulnerabilities. SonarQube is constantly scanning for security flaws based on standards like the OWASP Top 10, that's a well-known list of the biggest web security risks. It catches things like SQL injection risks or hard-coded passwords before they ever get out into the wild. It's basically your first line of defense.
Third, we have code smells. Now, these aren't exactly bugs. A code smell isn't going to crash your app today, but it's a warning sign of a deeper problem. A really long method isn't just hard to read, it's almost impossible to test properly, making it a perfect breeding ground for future bugs. These smells are the red flags of a code base that's becoming a real pain to maintain. And all those little code smells add up to something we call technical debt. What's so cool here is how SonarQube makes this abstract idea totally concrete. It doesn't just say, your code is messy. It gives you an estimate, in days or even hours, of how long it would take to fix everything. It turns a vague problem into a number you can actually track.
So, we know what it finds, but how does it fit into a developer's day-to-day? Let's take a look at how the analysis actually works. The whole process is beautifully automated. A developer pushes their code to Git, that push automatically kicks off a CI/CD pipeline, which in turn runs the Sonar scanner. The scanner analyzes the code, then sends its report over to the SonarQube dashboard. The developer immediately sees any new issues, fixes them, and pushes again. It creates this really powerful continuous feedback loop. But here's where it gets really powerful. SonarQube has something called a quality gate. This is basically a set of conditions that your code must pass to be considered ready for production. A really common one is requiring new code to have at least 80% test coverage.
So, here's the crucial part. If your new code doesn't meet the quality gate standards, if it introduces a major vulnerability or drops test coverage, the pipeline fails. The build just stops. Bad code is literally blocked from moving forward. It's a hard line in the sand for quality.
And SonarQube gives you even more control. You can use quality profiles to customize the coding rules for each language. It also highlights security hotspots. These are areas that aren't necessarily vulnerabilities yet, but are security sensitive and need a human to double check. And it's fantastic at finding duplicate code, helping you keep things nice and tidy. All right, let's bring this all together. How do you actually decide what's right for your team?
You've got two main choices. There's SonarQube, which is the self-hosted version you install and manage on your own servers. This is great for large companies with specific security needs. Then there's Sonar Cloud, which is the SaaS, or software as a service version. There's zero setup, you just sign up and go, which makes it perfect for startups and smaller teams.
SonarQube also comes in a few different editions. The Community Edition is free, and honestly, it's incredibly powerful. Then there are the paid Developer and Enterprise editions, which add more advanced features like branch analysis and more specialized security rules for bigger organizations.
So why does all this matter? Well, it matters because finding and fixing bugs early is exponentially cheaper. It means you prevent security risks before they become disasters, you make your code easier to maintain, you enforce consistent standards across your whole team, and ultimately you let your developers be more productive.
In the end, it really all boils down to this one simple promise. SonarQube acts as your automated guardian, making sure that every piece of code you check in is clean, secure, maintainable, and meets your high standards for quality.
So I'll just leave you with this one question to think about for your own projects. Is your code getting better with every single commit? With a tool like SonarQube in your workflow, the answer can be a definitive yes. Thanks for watching.